Alright, so we're going to find the derivative of these functions. So the point of these functions is to show us that we don't always need to use the quotient rule, even if it looks like we should use the quotient rule. None of these require the quotient rule. So first off, A, why does this not require the quotient rule? Well, because we can just heart this and have it become like x squared times 1/6 plus 1/2 times x. And then look how nicely the power rule just works there, no problem. You take the derivative, that becomes 1/3 x plus 1/2. You see no quotient rule needed there. And one of the beauties of quotient rule and calculus in general is you could use the quotient rule. You wouldn't get the wrong answer. It's just a lot more work than you need to do. And same with the next one. I mean, the next one you really just right away, it should be pretty obvious that we can just use the power rule. So we bring the 4 to the front, the 4 cancels, that becomes a 2. So it's 5x decreased by 1 over 2. That's very straightforward. The next one, notice how it's pretty similar, but like this x, so it's divided by x, so that kind of does make it look like you're going to need to use the quotient rule, but you can get rid of that x because it's in both of them up here. And then you can just like distribute that -3, and then I guess even heart it to make it obvious that they're going to be separate fractions. So that's just -9 over 7. And then plus 6 over 7 x. Because see, that's the only x that's left. And so now when you take the derivative of it, that's just going to be 0. And that x is just going to go away. The derivative of that function is just 6 over 7. So look how complicated that looks. But not only can you just use power rule, but the answer just ends up being 6 over 7 because it's just a linear function in the first place. They just made it look scarier. And then the last one is just to point out that if you have divided by x squared, we already know this, so we did it last chapter, I think, or last section. You can rewrite that to make it x to the -2. And then you can use power rule, no problem. You just bring the power to the front, so -2 times 9 over 5, and then you decrease the power by 1. Just recognize that decreasing the power by 1 means making it a -3. But then from there, that's the derivative right there. That's y prime. But it'd be nice to get rid of that negative exponent and simplify a little. So 2 times 9, -18. And then we could just put that x right back down there with the 5. So -18 over 5x cubed. So these are just to point out that just because these are fractions, there's no reason necessarily to use the quotient rule on these. You can if you want. It's just going to take longer and have more opportunities for mistakes. But if you do it all right, you should get the same answer.